Hello, this is Dr. Jack Jackson, and we're going to have a short little video here introducing gizmos. So, notice when we open up our wiki for the Probability and Statistics class, we can go to Introduction and General Information, and down here towards the bottom of this page you'll see a website for the gizmos and this class code. So the first thing I want to do here is just copy this, so Control C will copy in Windows, and then I'm going to click on this link to take me to the Gizmos site. Now, once you're here at the Gizmos site, there are a couple of different videos here that they have. One is Introduction to Explore Learning that you might want to watch, but we also have, we can enroll in a class. So we're going to do that right here. Click on Enroll in a Class, and this is where you paste in that code that we just copied. So Control V will paste that in, and so there's our class code. Hit continue, and this should allow you to come up with this class. Notice it does say the class that we're in, and if it's the correct class, which it is here, we're going to enroll in the class, and here we are. Now it may ask you, when you're doing this, it will probably ask you for a username and a password when you first do it. You will probably just see this one tab here under Probability and Statistics, and you'll see a number of different gizmos that we can access throughout the course. So in the first few, you'll see several gizmos here for the first couple of chapters. Actually, most of the gizmos actually are in the first, well, really in the second chapter, and then a couple of it in the first one. So we can, there's some information about that gizmo, or we can do Launch Gizmo. The assessment results is something that I have as the teacher. You may have some results for yourself, but I can access results for the class. But if you go into Launch Gizmo like this, this should come up with a gizmo for this class. Okay, there we are. Now once this thing loads up, of course you have to have a web connection for this to load up. But once it loads, you can even turn off your web connection and it will still keep running because it stores it on your hard drive temporarily. It'll erase it when you're done. So here we have a gizmo. You can participate with it interactively and just kind of explore with it. What these really are just little Java applets that run on your computer, and there are also assessment questions, though, as you kind of experiment with it, and then they give you some questions to see if you understand what's going on with this. And I would encourage you to do these. I may assign some of these questions for a grade later on, but go through these. I'll have some other videos on certain ones of the gizmos and show you how they work a little bit, and then have you experiment with them yourself. So that's a basic introduction to how to get on gizmos and get enrolled in the class. And then once you're in, normally you'll, instead of enrolling in the class, you'll just hit this button up here. Mine says log out, but it'll start with log in, and it'll ask you for your username and password that you set up. I would suggest please use your Lions Link email as your username. Well, you can actually use your name as your username. Actually, I think it asks you for your first and last name. But then for your password, just something that you know that that's going to be something easy for you to remember. Don't worry, I would not use something that's really very sensitive. Just something pretty basic for that. More on gizmos a little bit later as we go into some of our other lessons. Hello, this is Dr. Jack Jackson, and we're going to look at a couple of different gizmos and use those to help us get a better feel for some descriptive statistics. Now, we'll actually come back to these that are listed under Chapter 1 at a later date. We probably won't use those right away. But there's several gizmos here under Chapter 2 that we're going to take a look at. And I'm just going to start with the first one here and launch this gizmo. This particular gizmo, what it does is allows us to take some dots and just move them over here. So this will be constructing a dot plot. So, for example, if 45 is our first dot and then 55 the next one, and let's say 60 is the next one, we put a dot at 60. Next data we come to is 70, so we put a dot there. Say the next data value is 45 again, so another dot there. Then maybe we get another 60, and then another 45, and another 40. So say that's our data values. Okay, let's take a look at this. It will show us some different things. First of all, it'll show us the mode. Well, it's pretty clear, I think, that the mode is 45 here. It's the one that occurs the most often. The mean is right here at 52.5, and that's the balance point if we were to balance this out. You can also think of this as, of course, it's the average. Just add up the data values and divide by how many data values you have. And it's also the one for which the absolute deviations, or the deviations from the mean, sum to 0, not absolute deviations, but deviations. And it's the equal share amount, so that we left the total the same and spread all these out evenly, they would all be here. So in fact, let's see if we can figure this question out. How could I move the dots around here to leave the mean 52.5 but put them all the same? And the answer is put them all at 52.5, which I don't know if I can actually do with this one because it looks like it's going to only let us do it at a whole number here. But let's say, actually at a multiple of 5, but let's say the mean is 50. That's if they're all spread evenly. Now, if I did something like this, we would still be balanced and symmetric. If I move one down here to 80, where would I have to move another one of these that are in this tallest group, the modal group? Where would I have to put that to balance it out? Make a prediction. Okay, let's take a look. Were you going to have to move it below or above the mean to keep the mean at 50? Okay, right now the mean is above 50. Okay, if I move it above, the mean is going to go even higher. But if I move it below, it's going to move even lower, and it looks like right there we need to get it to balance out. Now let's do something else a little bit now. So now we have some data values like this. What if I were to add a data value to this and try to get the mean up to 50? Well, am I going to have to add it above the blue line, above 50 or below 50? Well, right now the mean is below 50, so to make it above 50 I need to move it above 50 to move it up. Oh, there it was, right there. That turns out to be the right place. Okay, let's add some more dots and change the mode. So if I added a few dots here, so it looks like this particular software will allow for a bimodal distribution. It'll count both of those as a mode. Let's see what happens if we put 3 on here. It even allows all 3 of those as a mode. But if we go here, for example, now we have a mode that's one clear value. Now let's add some more values and pull the mean back up to 50. Notice that we're going to have to add them above the 43.7 to bring them up. And in fact, if we're going to make it up to 50, we're going to have to add values above, well, up here. So let's add 1 here, and then let's add another one. Let's see if we can pull the mean up to 50. Okay, and then maybe add another one. Okay, there we go. Now we've got the mean back to 50. So here we have a different mode. Now let's take a look at the median as well. You can see the median is this value right here in green, so that's the one, so that half the data is below it and half is above it. Let's count the total data points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 data points. So let's see, we add 1, that would be 18, divided by 2 would be 9. we should see 9 values above. 1, 2, 3, 4, 5, 6, 7, 8, and the 9th one from the top, 8 above it. And then it's also from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, the 9th one from the bottom. So here we see 8 values above it, counting these two as being in the above category, and 8 values below, so that's the median. What happens to the mean and median mode if I take this value and say move it way down? Well, as long as I don't cross over the median line, don't cross over that green line, the median stays 50. But notice, the mean is moved. Okay? The mean is moved. I can take one of these values here and can move it over here, and now the mean is moved up. Now if I cross the median, then well, the green dot moved up one, and if I move another one across, oh, now we have a different median now. Now the median is 55. Okay, what's the distribution going to look like if I get, can I get one where the mean is above the median? There we go. Can we make the mean below the median? There we go, like that. We'll bring the mean down, but it didn't change the median. So if I'm just rearranging or moving around the ones in the upper half, as long as they stay in the upper half, and same way for the ones in the lower half, they stay in the lower half, I'm not going to be changing the median. But moving the data values around, just moving one around anywhere will change the mean at least a little bit. Maybe not rounded off to tenths, but it will move it a little bit. Okay. So it looks like even that's going to change it a little bit. But none of those change the median, or the mode for that matter. Okay. The range we can see is the distance from the highest to the lowest, and it is based as a measure of spread of that outer part. So it's the distance from the minimum to the maximum. But if I move around points in the middle, which really does make it more or less variable from the mean, for example, this data set is more spread out, for example, but than the one we were looking at a minute ago, but this is still a range of 80. If I bring all this stuff in closer to the middle, now we're much more consistent. For example, say here, but now the range did not change. So it gives you a visual interpretation of how you can change some things around and still visually see what's going on. What happens if you add a point? Think about all kinds of different questions. What happens if you add a point to this? What happens if you move some of the points around? What happens to the mean, the median, mode? Get on the gizmo yourself and experiment with it. Now, there are going to be some interesting assessment questions at the end. See if you can go through and answer these questions, because all these questions will help you get a better understanding of what's meant by the mean, the median, mode. A few of them are just computational, like what's the median of this data set. But some of them are, suppose what would happen if this is your thing, your dot plot, for example, and if you change it a little bit, what would happen? And see if you can figure out what those are and check your answers. Let's take a look at another gizmo that's got some of the similar ideas, but a little bit different one. Let's launch this one on line plots. Remember, line plot is another name for a dot plot. Okay, and this shows some computations, and this shows you the computation of the mean, the median, and the mode. Here's the data set in the order that we're coming up with. So it says it has, so we can take this data and sort it down here. and see that once we put it in order, there's 7 data items. So the fourth one in, 7 plus 1 is 8, divided by 2 is 4, so it'll be the fourth one from the left is also the fourth one from the right. That 5 is the one that is the median. What's the mode? It's the one that most occurs. The median, it will show you in green there, the mode, in red. How do you find the mean? You add up all the data values and then divide by the number of data values, and it shows you the formula there. How do you find the range? Take the maximum minus the minimum. You can see the maximum and minimum highlighted in purple, and subtract, and you get the range. So it gives you this one, rather than showing you graphically where the mean, median, and mode are in the range, it shows you the formulas for computing them. So again, some more practice problems and interesting questions down here. Let's continue on. This one is really cool. Let's go down here to Movie Reviewer. This one's a lot of fun. In this gizmo, you have a bunch of movie reviewers over here, and they give the movie a rating. 0 is the lowest possible, 10 is the highest. So they can give it a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So if you want a new reviewer, you just drag the card over. And if you want to get rid of a reviewer, you just drag him back over here to the cinema in the left. And you can go to the now standing order. So so we have this movie, Black Belt Gizmo. And let's see what we have here. We have several movies. Super Gizmo Saves Earth. Let's take a look at that one. And there's a preset data for that, so let's select it. And this is the ratings that we start with. Let's just suppose we want to add some more ratings to this. Let's say we're going to add a 4. Let's see, let's add a 4 here. Let's see, we should be able to add one. Let's see. Okay, it has its own. I think this has its own, and you can. I think we can go to a different one where we can do our own here in a minute. Let's see. Okay, so they're in order here. We can also balance them out, and so now notice that they're placed above the number line, and we want to move the balance until we can balance it out. And we find that balance point. What is that balance point? Well, that balance point is the mean. Okay? And so this gives you a nice visual of finding where that would balance out to find the mean. We can also stack them up, and it's just essentially like a dot plot. So let's take a look and see if there's another movie we can look at a different one. Let's select this one. Now this one, they're all, you can just list them in order. You can stack them up, and we can balance it out. Well, there's a whole bunch on this right side, so we're going to have to pull the balance way over here to the right to keep it balanced, for this one person way out here to balance out these 10. So apparently one person really didn't like this movie, but 4 people really, really did. We should be able to drag some more ratings over here. Let me see if I can figure out how to get this. But it calculates the mean for you as well, so that should be your balance point, and you can see the calculation of it up there. So this gives you a nice little visual of the mean. They have some, like I said, they have some preset data sets. This looks like we have a little bimodal type distribution here. Looks like these folks over here on the right, for the most part, liked the movie pretty well, and these over here on the left didn't. Got a nice little distribution here, those that didn't, and those that did, and there's not much in the middle. Okay, so there we can see the mean is 5.5. If you just put the data in order, you might be able to find the median of that as well pretty easily. Or you can do it from the stacked version as well. Now, if you clear this out, okay, I think this is how we can get new data sets. Okay, come on. We should be able to drag over rating cards here, and I'm not being able to do it right now. I'm not sure why this is not working, but this should give you a way to come up with your own rating. So you also do a random setting, and so here we have some data values. Okay, and again, where's the balance point going to be? Okay, it's going to be the right of 5. Where is it going to balance out? Or is it going to be the left of 5? Or is it at 5? Oh, it's close. Somewhere about there. What does it calculate out to be? About 4.8. Okay. Round it off there. Let's do another random one. Okay, I need to move it up a little bit. Somewhere in here. And so that's the mean. That mean is that balance point. Let's take a look at another one of these gizmos. This is another one that deals with mean, median, and the mode. So there are a series of these that are kind of similar. This one also shows us the balance point, which is the mean. And it also shows us the calculation. So once again, here we can add some data values. Okay, looks like they appear as frogs here on the other one. And so we can make our own little dot plot here, adding our data that we have. And if you move this around, you can try to decide where the mean is. Looks like we need to go this way a little. Okay, we're getting close. It's hard for me to get it exactly. It'll calculate the mean. I wonder if we can type it in. 6.75. It's going to round it off, so it's not going to do. It's rounding off to a whole number, to a tenth here, and we can't get it to balance out perfectly because of that. It will find the median. So this is kind of interesting. What do we do here? We have all the frogs start over here on the right side, and we need to get the number of frogs the same in both scales. We can, if it's an odd number, there will be a single frog in the middle. When's it going to balance? Okay, there it balances. So we have 4 data values, 4 frogs in this case, 4 dots in the left scale, 4 in the right scale, and so that means the data value will be between the 4th one from the top and the 4th one from the bottom. So in this case they're both 7, so we just average it and we get 7. If we added another data value, we've added another frog. Now we're going to have one in the middle. The one in the middle is the median. So let's add one more. Let's take that one off, but let's move this one down a little bit. Let's see, it's move it around like that. So now I have the same amount in each. There's 5 in each part, so we have 10 data points altogether. So the 5th one from the top and the 5th one from the bottom are tied for being the highest from the top and bottom. That's 5 and 6, so the median is 5.5. The mode will just be the one that is the highest, most often occurring. Here we don't really have one, but if we go to here, we can see this, and probably we can bring this to the top. So the top bar is there. That's the one that we see the most often. So that's going to determine what the mode is, which is 7. So kind of a cute little thing to help us visualize the mean, the median, and the mode. Okay. Box and whiskers plots. Let's take a look at that. Well, let's do stem and leaf first. Stem and leaf. Here's some stem and leaf plots. So here's our line plot, our dot plot up here. Here's our data set. And here's our stem and leaf plot. Let's see what we've got here. So if we start with our data set, and we want to go to our dot plot or line plot, we got to do a quick look and look like we probably could maybe start at 1 or 0 and then go up to around, looks like a 40 will take care of it for sure. And so we could run our number line from 1 to 40, 1 to 39, somewhere like that, and we should be able to check in most of our values. And then we just make that number line. As we see 31 here, we can place the dot right here over 31. We see the 19 next, we put a dot there. A 9 next, a dot here. 38, the dot is here. 37, here. 1 here. Now we already had a 1, so now we have our second dot for 1 in the top. You can also do your stem and leaf plot the same way. You start with your stems. Looks like our stems are going to be 0, 1, 2, and 3 because you have single digits, 10s, 20s, and 30s. In other words, 0, 1, 2, or 3 10s for the tens digit. And we can put the data in here to start with in the order it comes. So we could put a 31, so we put a 1 after the 3. 19, we put a 9 right here after the 1. 9 is 09, so you put a 9 here. Build this up like this, and then after you've got that done, then you can go back and put it in order. It gives you a nice little way to order it. Or, of course, if you have the line plot up here, you can also see it's already in order here. So we see 3 1s, that's these 3 guys here, a 3 here, 2 9s, then this is a 12, a 13, 3 19s, and so forth. Okay? So let's see if we can take this value and see the same value in all 3 data sets. Let's see. Of course, we can sort our data set in order, and we can see it there. If we click on a different one here, wherever it is, we can see it in all 3 representations. In all of these representations, there's actually a data point, either a dot or a number down here, or the actual data set. There's something for every single data value. Okay, let's look at another gizmo. Let's go to the box and whiskers plot next. So here, what this does is it has our dot plot, which we can build up by putting our dots on here, and at the same time it will find the box and whiskers plot. So of course the minimum controls the lower whisker, the maximum controls the upper whisker. The median apparently is right here, so I can move the median up or down. Okay, and then these are the quartiles. Okay, so this is a lot more variable here. We can put something, increase this, and make some dots wherever we feel like them. Move the dots around and see how dynamically how that's going to affect the box and whiskers. Notice if you're actually in the upper whisker, like these 2 guys here, moving these around That one actually is the quartile. Let's do this. Put another one up there. So this one's the quartile. Third quartile, that's the maximum. So these two guys, if I move them within this fourth, that's not going to affect the box and whiskers plot. But if I move this around, that will change the upper whisker, but not the other parts of the plot. If I'm moving stuff that's in here that's not one of the points on the ends of it, like this, that's not going to change the plot. But if I move this over the median, that's going to make a difference. Or if I move it up over the Q3, that's going to move Q3 around. Okay, this one, for example, is bimodal or doesn't have a mode. Now we've got a mode of 8. We could have the mode over here, and it's not necessarily the same as the median or the mean. And you can see how what's going to affect the data points as we have these 14 values. We can add more, and again see what happens. What happens if we put a bunch of these right here together? Then you're going to see this fourth of the data is very narrow in there, whereas this fourth is really spread out. In fact, we spread it way out there. Right? Might be really spread out. In fact, maybe even this one might even be considered an outlier, possibly, particularly if we make this more consistent. So this gives you a nice visual way of experimenting with some moving some dots around and seeing what happens to the box and whiskers plot. Again, go through and work these questions, because I think these questions will be very helpful to you. Okay, next let's look at a histogram. Okay, here we have some data value. Again, what we have here is really just a line plot or dot plot, and we have a histogram over here. Of course, if you just do a histogram based on a size of interval of 1, then basically the histogram and the dot plot are telling you exactly the same information. We're just drawing our bars to the tops of these lines here, where the dots are, tops of the dots. And we have a bar here for every data value here. But we can also group our information, so now we're grouping together. 1s and 2s together would be in this first bar, and 3s and 4s in the next. And so oftentimes when we're looking at a dot plot or just looking at individuals here on an ungrouped frequency histogram, so sometimes it's a few too many bars. Sometimes we can get a little bit better idea if we'll group things together and make it a little bit simpler in one sense, because we have fewer bars to deal with. So here's 2. We might even have fewer bars. There's 4. Well, you can see a nice little pattern going on there when you start grouping it that way. If you start grouping it too many, you just have too few bars. Okay, 1 bar is not useful. 2 is not very good either. 4 is not too bad. That's more like it. Now we've got 5 or 6 bars. That's more like what we want to be. Even this is pretty good. So usually you're going to want your groups to be such that usually you have somewhere from, I'll be pretty broad, 5 to a dozen bars or so. Usually 8, 9, 10 bars is a really good amount. So you can see again what's happening on the frequency histogram. Once again, all of these are counted all together, and that's the height of the bar for this first bar. Okay, let's see what's in this one here. I think this is probably the same basic gizmo. Let's take a look and be sure. Yeah, the gizmo is the same. The only difference here is going to be the questions down here. Oh, by the way, there's a table feature here. And so now we can have our intervals here and then our frequencies of the intervals. So this is the modal group, not necessarily the mode. when we go back here and ungroup it, we see that 2 is actually the mode, and the mode was actually in the modal group when we grouped them this way. So there we go. And depending on how we group them, you can see what's in the interval and what the frequency is of that group. And again, this is interactive, so if we want to move things around a bit or add some points in, we can do that and affect the size of our bars. So you can experiment with that. Again, answer the questions they have down here. I think you're going to find these are pretty interesting and helpful of understanding the concepts. Okay, let's just keep going through these real quickly. Elevator operator. Let's see what this one does. So this is showing the height of the elevator over time. And you can change its direction to go up. You can hit stop, go up. Maybe we can go up a few floors. Like that. And so this gives us a graph of where we are. And so we can replay it here. Now notice on the left you can actually see where the elevator is. So this is showing the height of the elevator, which floor it's on actually, which is essentially its height. And for the vertical axis, which of course is appropriate because it's actually going up and down. And then the time is going along here, left to right. So the horizontal axis is time, and you see that actually this little thing here that's moving around does actually progress from left to right as time goes forward. Okay, so let's see. We want to go up. Take them up to a floor. They could get off. Perhaps go up, down, stop, down. So we can get an idea of looking at what we have here. So then they ask you some questions about possible graph shapes there. So there's a broken line graph. Changes in the height of the elevator over time. Notice as we go back to that, let me point out something that's interesting about this. Since this is a change over time, it is appropriate to use a broken line graph. Also, notice that the elevator is somewhere at all times. So these points here, for example, between the floors do make sense, okay? Because the elevator actually between this time and this time actually is between the floors, okay? So as the elevator goes along here, we can look and see where the elevator is at all times. And so the line parts in the middle do make sense because the elevator does have a height at that time and it's between floors. So that does make sense. That's a typical feature of a broken line graph, that you'll have these data values in between that do make sense. This is going to be showing you some pictographs and bar graphs. So let's have some students make a vote, and then here is their favorites for mascot. 7 like the eagle, 19 the lion, 12 the bear, and 5 the wolf. And we can see that as a table. We can also see it as tally marks. So as each one voted, like looks like the eagle was first, we put a mark. Next was the lion, we put a mark. Then we have a bear, a mark, another bear, another mark, and so forth. When we get the 5th mark, we go across. So these are called tally marks, and we could put that as we go. We also do it as a pictograph. So each little check mark inside a box is 5 votes. So we see that the wolf got 5 votes, the bear got 5, 10, and some more. So we have to estimate what part this is of the total of a 5. So we could go over here and actually count them, but it looks like 5, 10, maybe 12. Let's count them. Okay, the green ones: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct. We can get the same information with a bar graph. Bar graph's a little bit easier to read, and if we want to make it visually appealing, we can include these pictures on the side. So I really suggest we use a bar graph rather than a pictograph. Here's the same information done vertically. Same thing. That's fine. You can do it that way. And we can also do this as a circle graph. Okay, so a circle graph or pie chart. This is really used again when we have categorical data like we do here: eagle, lion, bear, and wolf. And oftentimes we're interested in the frequency. Sometimes we're interested in the relative frequency, so we might put percentages on here instead. And we can have the dot plot of the values as well. So that gives you some different options there. So let's see if we have sort of 2 favorites, and we have them vote. So here we have 2 that were a lot more prevalent than the others. You can again look at the dot plot, the circle graph, the bar graph, turn either direction, pictograph, tally chart, or in the table. And either way you go, you have the same information. It's just different ways of representing that. So that gives you a nice little introduction to that type of graph. Let's see, did we do this one? Box and whiskers. I know we did the other box and whiskers plot. Let's see how this one is different, if at all. The actual plot is the same. So what you're going to see on this, on some of these, you may see the same thing twice, like the box and whiskers plots. These may be very similar gizmos, but the questions are likely to be different. Same way on like scatter plots activity A and B, I suspect is mostly the same gizmo, but different questions that go in the lesson. Now this one we're dealing with ordered pairs of values, so we're dealing with data and that has inputs and outputs. In this case they're both looks like positive real numbers, and so they're things that we can graph in the first quadrant here on our data plot. Now something we're interested in is it might have a positive trend. So it says in general as you go to the right it's going up. A general direction of going to the right, going up. Now that's not true for every data point, because right here we might be going down, but the overall trend is up. Okay, so here's no trend. More negative trend would be going this way. Perfectly negative trend, a perfectly linear negative trend. There's a perfectly positive, and this is more or less in a positive trend. And we might try to fit that to the best line that would approximate this. From your college algebra classes, you're familiar with this already, because a lot of what we did is we did a regression line, linear regression, and we found the equation of that line. I mean, we may talk about that a little bit more a little later. So this type of data is we call bivariate data. You have an input and an output, which are both real numbers that you'll be measuring. Not necessarily just counts like we have for some other things. We'll come back to some of the stuff with trend lines. Let's see what this graphing skill is. right here, and this will probably be the last one we look at in this video. Okay, let's see. Data shows how fast various kinds of animals can run. So let's see what we can do here. Okay, so this one we're supposed to create our own bar graph. So we need to go up to 112. There's 120, 100. 110 would be in the middle. 112, that's pretty close. 40 here needs to go up to that line. 56, there's 50, 80, 60, 56, might be about there. 72, maybe there. Humans, 34. We're pretty slow compared to these other animals, aren't we? An ostrich, 66. So a little, just under halfway there. So let's see how we did. 112, that's pretty good. 40, I did right on that one. 66. Whoops. That was supposed to be 56. That one's way off. Let's move it down here. There's 40, 56. That was off a line there. There we go. 72, good. 30, I only got 30. 34 is a little higher. And then I was a little high on that one. So you need to estimate these. Sometimes it's a little hard to estimate without a fine enough scale. If we make the scale a little more fine, we probably would have had a better chance at estimating these right. But it's not so good because you can't see the tops of some of the bars. You need to be able to see the tops of all the bars. You also need to always start at 0 when you're looking at these. Okay? And so this one does it backwards. Now you have the bars and you have to go and create the table. That's 21, so we type that in here. High school, that looks like 30. Let's see. Yep, 30 is correct. What do you think on the yellow one? Between 30 and 40, a little closer to 40 than 30, maybe 32 is my guess. Let's see how we did. Oh, 36. Oh yeah, definitely 36. Definitely closer to 40 than 30. This one is almost 50, 49. Yeah. The next one, really close to 60. Looks like 59 to me, but could be 58. Let's take a look and see. 59. And this is between 70 and 80, 74. Yeah, that's good. Okay, so what is this saying? The bar graph is supposed to show how education is related to yearly income, and these are probably some sort of average income in thousands. So on an average, high school dropouts are making around 21,000 a year. High school diploma, 30,000. 2-year degree, 36,000. 4-year degree, 49,000. Master's, 59,000. And with a doctorate, I should be making 74,000 a year on average. But I went into education. So we can also look at this in terms of a line graph. Now, this one would be growth over time. Okay, so we can see there. By the way, the bar graph was appropriate for categorical data. This is actually ordinal because there is an order to this, higher and higher education, but it's not really. It's a discrete and it is ordinal. It's not ratio or interval. If we go back to line graph, this should be some sort of continuous, either ratio at least or interval data, and in fact this is ratio data going over time. So years since birth, and you can see that, and you can read the values off of here and then put them in over there. Pie chart should give us percentages or frequencies or relative frequencies. In this case it's relative frequencies with percentages, and they're actually written right there, so it's pretty easy to write those over in the table. And with the scatter plot, we have an input and output variable. Usually these are both some sort of continuous variables. In this case, temperature and water, so we're measuring, for example, on Monday we measured the temperature and the water and so forth. And you can see they're color-coded, so for example, the blue one here is Tuesday, and we can read off the input is the temperature, 30, what do you think, 37 maybe, and the output is about 2.5 or so, yeah. So we would type in 37 here and 2.5 here and so forth. Okay, and it'll create a new one, new values there. So they have several to go with. So we can go from the graph to the table, or from the table to the graph. So we can make a scatter plot here. So for example, we should probably be able to take this dot here and put it at 40, 98. So let's see, we need to do 40 here and 98 here. Let's see, right there. Okay, and this one at 558. 5 is going to be in the middle here. 58 is almost to 60. There we go, 558, and so forth. In a pie chart, we're going to have to adjust these wedges here to increase or decrease. Now these are already percentages, so we just got to match the numbers. 36% for apple. Pecan is 26%. We need to make it a little bigger here. There we go. Pumpkin, 12%. It's a little bit too big, so let's make it a little smaller. 12 right there. Cherry. Let's be looking at favorite pies. Yeah, that's what we're doing. 8. And the other was 18%. So there we go. Now, if you're going to finish your chart, you will need to put something about a title in here. That's going to be important. So we might title this one Pie Preferences. And of course we should probably also somewhere along here cite what kind of source that we have for this. You can do a new one of the same kind. Okay, and you can also do a different kind of graph, like a line graph. Okay, so here we have time here, and we have the temperature data, and we're showing how it's changing over time from 8 to 19 to 27. Looks like we've been going up for a while. To 31. But maybe it's peaking out there. It goes back down to 29. And then drops back down to 16. And then finally ends up at 13. And so that gives you an idea of how the temperature is changing throughout time. So a little practice with making graphs.